Okay. Hello, everybody. Can you hear me? Okay, cool. So, my name is Pavlo Golub, and they think that I'm a senior consultant, but I prefer to say that I'm a young developer inside. The funny thing about myself, when I studied in the university, the thing I said that I will never do anything with databases, and here I am, right? Okay, so a couple of words about Cybertec. So we are Postgres company. So to be our client, you need to run Postgres. If you don't have Postgres, we will run it for you, and now you can become our client. So at the moment, we have 6 offices all over the world, and we are working on opening office here in India. I hope soon, this year, we will be presented here. So these are our main projects we are working on, software projects. So if you want to know more, find me after the talk and I will explain, show what are they. So you know why PostgreSQL, I will skip it. So agenda, I will explain the different levels of database monitoring, what approaches and we do for monitoring PostgreSQL servers, what specific tools for Postgres do we have in the field, and at the end I will show our own open source utility called pgwatch 2, which is pgwatch 2 because nobody knows what is pgwatch 1. People said that was like a funny Python script that we used like during the dinosaurs era, So the only thing we know is pgwatch 2 and pgwatch 3, what is it, and how it became possible. So why we want to monitor? Silly question, right? First of all, we need to know if we are running a system or not. We want to know, is it fast or is it slow? We want to know what we need to do to make it better, to make it worse, I don't know, to upgrade, etc., etc. And maybe we want, based on these decisions, on this data, we want to know how to maybe waste our money or save our money. So the first level of monitoring would be the high-level service availability. So there are 3. I divide them into 3. So the high-level system availability, then the system monitoring, I would say operating system, right? And then the PostgreSQL, so the specific level. So what is high-level service availability? We want to periodically connect to the PostgreSQL and to know if it's alive or not. Really simple. You can do it with your own tools, cron, schedulers, whatever. But the thing is, and for most of the clients, for most of the people, it's enough. I just need to know that my database is running, okay? But who will guard your script that is running? How do you know that it is running, right? Then system monitoring, and we are talking about system like an operating system and the cloud. So there are too many tools, no real standards, and sometimes you have no idea what you are measuring. For example, what is like CPU, virt, res, share memory, whatever, I don't know. I'm a developer, I don't know. Maybe you know. What about PostgreSQL and specific PostgreSQL things? I will split it into the 3 areas. First one is analyzing our logs from PostgreSQL. It's really good. So you need to analyze logs always. This is the first place where you should come if you have kind of problem or questions or whatever. The second one is the statistics collector. It's a set of views and tables built into the server, so you can so we can query them with the SQL. And the third one is external extensions that will provide you with even more information. Okay, so how we people do log analysis. Sometimes people just gather all the logs and save them somewhere for later processing, right? But we know that this time will never come, so we have a lot of logs, and that's it. You can do active parsing with your own tools, or we have like this file foreign data wrapper that you can read from the log file from the SQL. I would say that standard de facto right now is the PG Badger. It's really good. It's actively developing, so give it a try. Grafana Loki is the application software that released not so long ago, and it focused on the log processing, so yeah, try it as well. About configuration, there are, first of all, we have 43 different login configuration in PostgreSQL. This is information from the Postgres 17. And each major version adds more and more and more. I recommend that we go with a CSV format, because usually we want to analyze our logs, and this is the best format we have at the moment. We also have JSON format, but it's quite chatty, that if you say JSON, your logs are much bigger than CSV. So log statement, it's up to you, but we have known by default. You need to set minimum duration statement and duration and minimum message and minimum error statement. About statistics collector. Statistics collector is a set of views and tables that are present inside our server, so we can query them and get the particular information. Be aware that not all configuration parameters are enabled by default, so you may probably want to enable them in your configuration file to have even more information in the collector. So all statistics collector views and tables are divided into two kinds. First one is a dynamic and another one is cumulative. Dynamic shows you what is going on right now, like a snapshot, like stat activity, the number of connections, the number of sessions, the number of queries, like that, the number of logs. Cumulative, they provide you the information from the beginning of, of something, of the start, or from the beginning of reset, and they hold in information and sum it. So, for example, how many statements were executed from the beginning of time, and each time you query this cumulative view, you have a bigger and bigger number. So that's why if you want to analyze a problem, for example, you came to the client and you need to understand what is going on, the first thing to do is reset the statistics and then run the workloads for some time, if you have a day, hour, whatever, and then analyze the fresh statistics. Because otherwise, you will be looking on the workloads, on a history that you don't have an idea what's went there. Extensions. So the most famous is PG start statements. I believe it should be on by default. On all installations. Another one is a PG stat monitor. I believe it developed by Percona. So it's like a PG stat statements, but with additional fields in it. PG stat tuple allows you to see how bloated your table is. PG buffer cache allows you to see inside your shared buffers. Auto explain allows you to log the statement, the queries. You can configure it, the trigger to long queries or queries that take like more than 5 seconds, something like that. pgwatch allows you to investigate where statements of your queries. Are they good or are they bad? And pgstat-kcache allows you to access some operating system metrics. And of course, not all of them are available on cloud. I would say none of them. pgstat statements is, but I mean all others are probably available only if you are running your own server. What's real life? So in real life, we do like a lot of like mixed approaches. First of all, of course, we are collecting some logs and store them somewhere and analyze them somehow. And then we probably continuously monitoring our pgstat statistics collectors. And we are trying to analyze and to predict what will go. Another way to go is to use the application performance monitoring. But we will talk about it later. Okay, so about the PostgreSQL. What tools are available for PostgreSQL? So there are a lot of them. If you want to find all of them, please follow this link. And of course, if you write a new one, please add so we know we have a new one. There are like 20 plus, I think, at the moment. So ad hoc troubleshooting. For example, I'm at the client's office and something is going on. I need to see inside the database what is going on. Of course, I have PSQL, I have pgadmin, whatever. I can do that and that and that. But we have a bunch of simple utilities that specifically doing that. PG activity, PG center, PG top, PG hero, pgadmin, edbeaver, they are not monitoring solutions, but they do have, this monitoring section with the simplest dashboards where you can at least see what's going on. Not much, really. So my favorite is a PG activity. So it's a Python program. It's with us like for long, like maybe 10 years, maybe something like that. So, and I like it because on one screen you have a lot of information available, and you can switch between queries, waiting queries, blocking queries, etc., etc. For example, I myself used it when I had a long-running transformation with many steps. So I constantly monitor this program, and I saw, okay, so we switched to stage this, so probably we need more 1 hour and we are done, something like that. As I said, pgadmin has simplest dashboards. Don't think it's really useful for real life, but I mean, dbeaver has only 3, and that's all. So if you want to add more, please do so, because dbeaver is free and open source. And now we want to talk about continuous monitoring frameworks. So we have a bunch of commercial. And here I want to, probably you know Datadog and AppDynamics, New Relic, whatever. We have generic open source that can be used to monitor Postgres, but they are not like focused on it. And they probably use check Postgres is the first version, or a Prometheus exporter script. And Postgres specific, the tools that are only for PostgreSQL. pghero, Pova. Pova, by the way, is the team behind Pova are the developers of these extensions, pgwatch, pgstat-kcache, and pgwatch-sampler. pgclue, the really lightweight pgstatviz, which was presented last year during the European conference, and the work on the pgstat was done as well in the Google Summer of Code with the one student from India, and pgwatch 2. Okay, so pgwatch 2. I said before that we have a lot of monitoring tools. Why we, Cybertec, came with another tool, right? First of all, I want to thank Karl Moppel. He is the author of pgwatch 2. He put a lot of effort in this software. Thank you, Karl. And why? So the main principle is 1 minute setup. So you have like a USB stick with you, or okay, you have an internet, right? So you can come to the client, you can run it immediately, and you can immediately start showing how your system behaves. We want user to be allowed to change dashboards. So we came with a preset of dashboards. There are a lot of them, like 50 maybe. But okay, you don't need all of them. And probably you want to put on your main monitoring screen only those that you are interested in, right? So if you are interested in maximum connections, you will put it. If you are not interested in CPU or other like things, you will not. It should be non-invasive, because especially with a lot of cloud installations, you usually don't have this superpower to put like external extensions to build your extensions, etc., etc. So you need to operate with the tools you already have. It should be easy extensible, and it is, because every metric is just a regular SQL script. So if you want your own, you just change we provide it, or you write your own metric. It's a simple SQL. And if you want alerting, you can implement it with the Grafana dashboard. They allow that. We don't do alerting. So architecture. So the application is a Go software. You can configure it with databases, with files, with environment variables. And when we measure something, we then store it somewhere. The first choice is a PostgreSQL, because we are a PostgreSQL company. We support TimescaleDB. We did support Influx and Graphite, but we deprecate support for it because we don't see much sense. PostgreSQL is good enough already to handle everything. And the Prometheus, of course, because like Prometheus nowadays is like a standard de facto in the monitoring world, and we can store the measurements into the local file. 5 years ago, I was like, why local file? Why do we need local file? And now when we have a lot of these AI, ML things, you know why? Because you can ship the local files to the model and try to play with it, try to predict, try to analyze, try to see what's going on. Web UI for administration, and of course Grafana for your dashboards. Okay, so this is how it looked. So we have like a daemon which collects a lot of metrics from databases. So we tried, and our metric collector can hold up to 500 databases at once, no problem at all. The only problem with the storage engine, if it can suck really fast. So, and then we store our metrics somewhere, and then user can see what's going on in the dashboarding. Okay, so features. Everything you can imagine, every statistic collector. So we support from 9.0 for pgwatch 2 for current version. For the next major version, we will switch to PG11. I mean, because I'm not sure there are many 9.0 or 6 servers in the wild anymore. Okay, so another features. auto-discovery. So if you have a dynamic environment and you constantly creating or deleting databases, for example, you allow your customers to create databases, or you create databases for every specific project or whatever, you don't want to put every time through the web UI or through the environment or whatever a new database under monitoring. You want to have them all, right? So the feature of auto-discovery is that daemon every 2 minutes will check if there are new databases and will automatically add them under monitoring. And if some databases are gone, okay, we forget about them. We can detect the changes in table indexes, procedures, etc. Of course, we have support for cloud, for AWS, for Google Cloud, for Azure, for whatever, yeah. And we have specific metrics for PG bounce or PG pool. Not much, but I mean, if you're interested, that's cool. We have full Patroni support. The same, if your Patroni cluster is running, you don't need to add every database under monitoring. You just provide the connection string to the Patroni, and pgwatch will find all the cluster members and will add them automatically under monitoring. As I said, very low resource requirements. And yeah, it's extensible because the metrics are like plain text. As I said, alerting should be done via Grafana, or you can write your own alerter, which will connect to the pgwatch, for example, through Prometheus protocol, and will constantly check the new messages, new measurements, and will react accordingly. Or you can write a scheduler job that will analyze the collected metrics and will do the job. So if you want to see how to run it, we provided just like the simple Docker image. So you run it, you wait for a couple of seconds, well, minutes, while it will be started. It will start to collect the things. Then you can add your test databases, and you can start and then view and edit all the dashboards. But if you are lazy, as me, you can go to the demo pgwatch.com and you can try how it looks like in the real life. So here is the like basic health check dashboard with green, red dashboards panels to show you how we are doing, for example. And of course you can set, for example, instance uptime. By default, it will be red if instance is up less than like 4-5 minutes. But if you are like in very dynamic environment, you can either remove it or change it to another threshold. For example, PG version number, it's green, right? But you can set it that like if the version of database is if it's lower than 16, we are going red. Why is that? Because we need, constant reminder that we are doing something wrong. By default, as I said, we have a lot of dashboards. Here, all they are. So you can check statistics about state statements, databases, tables, execution, whatever. You can compare the previous loads with the log with nowadays. For example, you can see like the biggest relation tree map. So for example, here we have PG bench accounts, and we can compare the tables with indexes, without indexes, etc. But that's not it. We choose Grafana because it allows you to be very, very dynamic, to be very flexible. For example, our partners, pgwatch or Postgres.ai, they did their own set of dashboards. This is absolutely open source. You can find it on GitLab. So what they did, they grabbed the whole thing, the binaries and everything from Cybertec, from our repository, and then add their own extensions and dashboards. And they have like pgwatch.postgres AI. I don't know if you can see it. So the demonstration. So comparing to our predefined dashboards, they are doing it in different way. They divided all panels and all dashboards in 5 levels. So first level is a global level. I mean, I'm interacting with the whole server. The next level, I want to know about specific database. The next level, I want to know which queries are running on this database. Then I want to know something about tables and the indexes, etc. For example, if you switch to the database level, then you can see, then you can select, for example, which database you are interested in, and then you see a lot of different metrics which you can, of course, change. But the main difference of their approach is that their dashboards are very long. They're like 3-4 screens. We are not like that. We are doing that all our panels are going on one screen. So we can constantly take an eye on it, right? So it's up to you what to choose. Okay, so I show you the dashboards. So pgwatch 3, what's about it? Carl, my colleague, after the COVID, decided to switch from his role and decided to pay more time to the family and kids and whatever. So my boss, Hans-Jürgen Schönig, oh no, this is the better. So this is my boss. So he wrote to me, "Sir," and I know if Hans wrote "Sir," something is going on. So he said, "We want you to maintain the pgwatch." And okay, I cannot say no, right? Because I like programming and whatever. And my second reaction, okay, now I can do anything I want. The thing is that this is what was not my code base, and the support took a lot of efforts. And we already knew that we want to have more features there. For example, we wanted to use the latest Grafana possible. So, for example, we don't depend on the version. We wanted to use more robust, more compressed storages. We wanted to make new web UI. We wanted to make a lot of changes there. So I decided to go with the pgwatch 3. And from the, I don't know, I made 343 commits. Not too much, but those are squashed commits. So this is like a roughly number of pull requests. And before that, you have this kind of web UI, and now you have this kind of web UI. Before you have this kind, oops, sorry. Now you have this one. Before dashboards were like this, not because we did, because we used like the outdated Grafana. It was like Grafana 6 something. Now we are running the latest Grafana possible. This is 10.4. Now, we added TimescaleDB as a default choice. If you want to store your metrics, to measurements in Postgres, you can run TimescaleDB, install TimescaleDB, and this will give you this. So with compression is on, of course. So for example, 45 million rows, that means real live data for 6 databases for 3 months, right? Well, it will cost you 70 gigs before TimescaleDB. Is it much? Well, it is, but by default retention period is 2 weeks. So our measurements, our metrics will never grow higher than half of gig, something like that. So only if you say that I want retention for longer period, you can accumulate this data. Okay, so storage of 70 gigs with compression enabled became 8 gigs. And we are working on the new feature, so without TimescaleDB, we will have like 11 gigs, like 7 times less. And with compression ratio, it will become like very, very funny number. Okay, what really important change? So we introduced the term sync. So we get the metrics, get the measurements from our sources. Sources is database, sources is pgpool, pgbouncer, sources is Patroni, right? We get the measurements and we want to save them to sync. And in previous version, every sync was only one, so you can specify only one sync for your workload, right? Now we can do it in parallel. We can put it into JSON, we can put it into PostgreSQL, and we can serve it over Prometheus all at once. All at once. And more to come. We almost finished the RPC sync, which allow you to create your own implementation of syncs. You will just get the measurements, and we'll put them. Put them, or you can make your own alerter or something like that. So as I said, we have a lot of metrics, 73 metrics by default. Not all of them useful, of course. We have metric for PG backrest. If you don't use it, don't enable it, right? Okay, and then Docker images became less. So for example, our default Docker image was 1.17 gigs. It's not much really, okay? So disk is cheap, the internet is cheap, but what if you work in Kubernetes or whatever and want to deploy the pgwatch as a sidecar? It's became a problem. So we still have like a pgwatch demo container if you want just to run it, show everyone how it's working. But the working horse now is pgwatch, which is like 44 megabytes. And instead of that, how many time do we have? Okay, 5 minutes. Oh, okay, let's try. So now, let's do a live demo. I want to fail, right? So okay, I'm in the repository of pgwatch right now. I'm on master, so you can try right now. So what I'm doing is I'm trying to type, right? Docker compose, detach, up. So what I'm doing is I'm using my Docker compose, which is provided by default, and we see that our Docker starting Postgres, immediately starting Grafana, and immediately starting pgwatch. So here's how it looks like. Can you see it? So we have like 3 services. One of them is Postgres, but you can change it to TimescaleDB, whatever, or you can change it to your specific image. Just build your own and put it here, right? Then we have Grafana, which connects to the Postgres, where we save our measurements in the displays. We have pgwatch running on the same node. So let's try to connect. First of all, let's try to connect to our administrative UI. We run it by default without authentication, so put anything you want and you are done. Okay, so we have 0 sources, right? We don't have databases to monitor. But we can already change metrics we have. For example, archiver or like 75 of them, remember? we have a concept of presets. Of course, you don't want to put 27 metrics and enable them by one, right? So we have special presets for clouds, for full, for exhaustive, for anything. Create your own preset if you know exactly what metrics you want to run. Then, if we want to run a test monitor database, we can use a special service in Docker Compose. DC is Docker Compose. So it goes add testdb. For each monitoring database, we want to have several extensions. First of all, pgstat statement, right? Then sometimes we want to have pl Python if we want to measure CPU or something very system specific. And we want to grant usage privilege, for example, on pgstat file for our daemon. So these are the statements that I'm running against my monitor databases. But you don't need to do that. I do it only because I want to show you how much we can do with enabled extensions. But you can run the vanilla Postgres with vanilla database. The only thing we need is pgwatch user will have the pg monitor role in it, okay? And then, of course, we have a special pg bench servers, which allows you to generate some loading. And while it works, we have 4 minutes left. Let's see what can we, so this is web UI, right? And now you can see that we added the one source, but we can add more. Like, let's copy this one because we know that this is working. This is, we can check if it's working, okay. So let's say we want, so this is preset, okay? And tags, for example, for this, because we use the same database, I want to distinguish it, right? So I will say this is special pg hit 42, right? Add tag. So now every metric, every measurement from the new edit will have this tag. So the database is the same. The tag will tell you from which preset or from which installation it comes. So, yeah, of course. Okay, so pay attention. We have two databases, the same databases, with the same set of metrics, but we can distinguish between them. Even more. For example, if you want to have different settings, if your database is primary or standby, you can have this. So you put you put two sources and specify that for this one I want to measure it in that conditions, for that in that conditions. Okay, and okay, we can now. I hope that we have some data generated. This is localhost 3000, and we switch to 5 minutes because our database is just started. Okay, we can see something, right? So now we can play, we can see what's going on. We can dashboards, for example, health check. Let me show you. You see, instance uptime is 5 minutes and it's yellow. And you can set your own threshold to say, should it be yellow, red, or green. And the device, of course, is 17 because we do all our tests on 17 beta. Okay, is there something I want you to show more? I'm not sure. So if you have any questions, it's time. Okay, thank you. So the question is, if you add your database twice, would it be collect measurements twice or would it be collected once, right? Yes, great question. So if we repeat the same settings for the same databases and edit it 2 times. Internally, we know that some metrics are global for cluster. So of course we don't do this. But if for specific metrics, we do combine, we do request them because the execution time may vary. And if we will say, okay, we will use that metric, but we will just add another tag, something may go wrong. For example, some metrics, some heavy metrics could be executed up to 5 minutes. It's very bad case. You shouldn't do that. But I mean, if client wants that, we are allowed, right? So yes. So global, so the cluster level metrics will be gathered once. They are cached, like CPU, like the size of tables, like the available disk space. That will be gathered once. But the table level metrics or the statement level metrics will be gathered twice.
I have a question here.
Yes.
You mentioned that you can have two sources for the same database, and they can switch between having different metrics for when it is a leader and when it's a slave, right?
Yes.
Or a read only.
Yes, yes.
So is it possible to do that automatically?
Yes, it is. We have special metrics tab. So if you are primary, you set it here. If you are standby, you can choose another preset, basic. So for example, if I'm primary, or vice versa, you know. If I'm primary, I want to do less. If I'm standby, I'm fine. So yes, you can specify different presets or even different metrics or even different settings for standby and primary roles. And pgwatch will switch automatically if failover or whatever.
Yeah. One source will have A and B, the other will have B and A, something like that, right?
No, you need only one.
Only one.
So I added second one just to show that it's possible.
Okay.
So usually in real life, you add one and you put the settings for primary and for standby.
Okay. So the source will be the same, but the preset is the one which keeps switching based on if it's read only or not.
Exactly. Okay, so we don't have time anymore. So if you have questions, please find me offline. And can we have one question?
Means like if we don't have this UI, generally from the backend we can add our custom queries and integrate.
Yeah, exactly. So you have, the question is, we have on our database, people tried, of course, our soft, so they have pgwatch 2 database and pgwatch metric database. They are different, so pgwatch is for configuration. pgwatch metric is for storing your measurements, right? So if you don't want to use database as a configuration, for example, in real life, you want to use files, right? So you can specify all your sources in files and just provide it to this source. So you will end up with the pgwatch metrics only. If you are using the config file and Prometheus, you are free. You don't need to use Postgres anymore.
Got it. So the same database setup will be present in pgwatch 3 as well.
Yes. So we think that the main approach would be to use config files because it's more flexible. But now we provided the API, REST API. So you don't need to update the database manually if you want to add something. You can speak directly to the pgwatch with the REST API and say add metric, add source, update, delete, pause, ping, whatever.
Thank you.
You're welcome. Thank you.